Good morning. Today's topic is electrolysis. So, before discussing electrolysis, let us see what is an electrolytic cell. It's a cell containing two electrodes, positive electrode and negative electrode. Positive electrode is called as anode and negative electrode is called as cathode. It is connected to a battery and these two electrodes are dipped in a solution which is molten NaCl, that is NaCl solution. So, these electrodes are dipped in NaCl solution. Okay, so this cell, electrolytic cell, is a cell which converts electrical energy into chemical energy. Electrical energy to chemical energy. And it contains two electrodes. Negative electrode is called as cathode and positive electrode is anode. Okay, so what happens when current is passed through this? What happens? The positive ion, that is the cations, will move towards the negative electrode, that is cathode, and negative ions will move towards anode, that is positive electron. And this process is called as electrolysis. Okay, so this process, the process taking place in an electrolytic cell is called as electrolysis. Okay, now according to preferential discharge theory, according to preferential discharge theory, ion which discharge first requires less energy. Okay, so ion which discharge first requires less energy. Okay, so the ion which requires less energy will discharge first. So this process is called as electrolysis. Now let us see different types of electrolysis are taking place depending upon the electrode and the solution we are using. The different types of electrolysis are taking place. Let us discuss one by one. First case, electrolysis of NaCl solution using inert electrons. Electrolysis of NaCl solution using inert electrons. Inert electrodes means the electrodes where no reaction is taking place, they are inert. Okay, and the solution will be NaCl solution. Here what happens? Actually NaCl is present, they get ionizes as Na plus and Cl minus ions. Okay, also water is present, that also ionizes as OH minus and H plus and OH minus. H plus ion and OH minus ions are obtained. So what happens at anode? At anode is the positive electron. Okay, Cl minus ion, discharge of Cl minus ion is taking place and from Cl2 and 2 electrons are released. Okay, now at cathode what happens? Cathode, what happens? Here at cathode, H plus ions accepts those electrons, okay, and form H2. H2 gas is evolved at cathode. So according to preferential discharge theory, H plus ions instead of Na plus, H plus ions are discharged and form H2 at the cathode. Okay, so here in this case we know there are H plus ions are obtained. So what happens to the pH? pH of the solution increases during this electrolysis. Now second type, electrolysis of NaCl solution. The solution is NaCl, but the electrodes used using mercury as cathode and graphite rod as anode. Electrolysis of NaCl solution using mercury as mercury electrode as cathode and graphite rod as anode. Okay, here what happens? So in this case, same, NaCl dissociates to Na plus and Cl minus ions, and H2O to H plus and OH minus ions. Okay. Now at anode what happens at anode? At anode, say 2Cl minus gets converted into Cl2 and 2 electrons are released. Okay. So here 2 electrons will move towards cathode. Okay. So what happens at cathode? At cathode what happens? At cathode, this instead of H plus here, Na plus gets discharged, because the discharge potential of Na plus is less. So less energy is required, where is less than H plus towards mercury. If we are using mercury electrode as cathode, Na plus requires less energy to discharge. So here Na plus gets discharged and these 2 electrons are added and form 2Na. Okay, sodium metal is obtained at cathode. Okay, this is due to the discharge potential of Na plus is less than H plus towards mercury. So Na plus discharges at cathode. This is the second process. Now the third process. Third one, electrolysis of very dilute NaCl using inert electrodes. Okay, electrolysis of very dilute NaCl using inert electrodes. Okay, what happens? Using inert electrodes. Now in this case, NaCl ionizes as Na plus and Cl minus, H2O ionizes to H plus and OH minus. Okay. Now at anode what happens? At anode OH minus gets discharged, because this is having needs less energy for discharge according to preferential discharge theory. So what happens? H2O plus half O2 plus 2 electrons. Okay. So at cathode what happens? Cathode, H plus accepts those 2 electrons and H2 gas is liberated at cathode. So in this case, equal amount of H plus and OH minus are consumed, because at anode OH minus, cathode H plus. So equal amount of H plus and OH minus are consumed. So in this case, no change in pH is taking place. No change in pH. Okay. Now, next process, next electrolysis. That is electrolysis of copper sulfate solution. So instead of NaCl, we are using copper sulfate solution using inert electrodes. Electrolysis of copper sulfate solution using inert electrodes. Okay. So what happens? For CuSO4, ionizes and form Cu2 plus SO4 2 minus. Okay. Now H2 also ionizes and form H plus and OH minus. Now at anode and cathode what happens? At anode OH minus gives H2O, then O2 is obtained and 2 electrons are released. H2O plus half O2 plus 2 electrons are released, and Cu at At cathode, copper ion will be there. Okay, so Cu2 plus, what happens? Cu2 plus accepts those electrons and form copper. Copper gets deposited at cathode. Okay, so in this case H plus interacts with H plus ions are present in the solution. These H plus ions interact with SO4, 2 minus ions are also there. They interact and form H2SO4. So sulfuric acid is obtained. So what happens to pH? pH increases during this electrolysis. Now there are few more electrolysis are there. If we are using copper electrode at anode, what happens? If we are using copper electrode at anode, if anode, instead of anode we are using copper electrode, what happens? And also at anode also we are, cathode also we are using copper electrodes. If we are using copper electrodes at anode and cathode, what happens? At anode Cu2 plus ions are produced. So here what happens? At anode the amount of the weight of the anode decreases. At the same time this Cu2 plus move towards cathode and gets deposited at the cathode. Okay, so weight of cathode increases whereas weight of anode decreases. Okay, so this is the process if we are using copper electrodes as anode and cathode. Now there are some other process also, that is acidulated water, that is water containing H2SO4 is used. Okay, if we are using acidulated water using inert electrodes, and the electrodes are inert, and we are using acidulated water, that is water containing H2SO4. At that case what happens? H2 and O2, hydrogen gets deposited and O2 gets deposited, and if H2 is formed at anode and at cathode O2 is evolved. So H2 gas is evolved at anode and O2 gas is evolved at cathode, and they are in the ratio 2:1. So there are different types of electrolysis are taking place. This much about electrolysis. Okay.